Ladies and gentlemen, on today's episode, we welcome on Fisheries Research Scientist with the Wisconsin Department of Natural Resources, Colin Dassow. So we chat with Colin about 3 separate research projects that he's been a part of recently that take a critical look at the common characteristics of lakes with trophy bass potential, a pretty shocking hook avoidance study, and the tendencies and co-mingling of pike and musky. All that and more on this episode of Tackle Talk.
Hello, everybody. I'm Bill Dance, and you're listening to Tackle Talk.
This is the Tackle Talk Podcast, brought to you by American Legacy Fishing and Outdoors. World-class fishing gear, unmatched personal service. Now, here's your host, Andrew Hayes.
Hey everybody, welcome back to another episode of the Tackle Talk podcast presented by American Legacy Fishing. And folks, we have a treat for you today. In our never-ending pursuit of a well-balanced podcast here, giving you a healthy mix of gear talk, news, tips, and science, today we focus on the last one as Fisheries Research Scientist Colin Dassow stops by. And this is one of those really interesting, really practical episodes where this research is going to directly apply to you as an angler out there on the weekends or out there this week, the next time you go out fishing, actual information you can take and use on the water. For instance, the first study that we talk about today focuses on what specific characteristics their research identified as being the common overlapping features of lakes that had trophy bass potential. Basically, meaning what should you look for when you're looking for a new place to fish? And the answers might surprise you. I know they surprised me. And then the same thing can be said for the second study that we talk about today, which takes a long look at hook avoidance and learned behaviors of fish that are hooked multiple times. So when a fish is caught, how long before it can be caught again? Or what are its tendencies moving forward? Is it going to avoid hooks at all costs? Is it going to take some time to be rehooked? All of that information is covered in that study, and the data that he's going to go through on that study kind of flipped almost everything that I thought I knew right on its head. And third, we have a really interesting ongoing study about musky and pike living together and how they differ in terms of how they act and their tendencies from species to species. So we've got a little bit of everything today. What should you look for before you go fishing? What should you know about catch and release fish after they've been caught multiple times? And what does fishing pressure have to do with it? And then a little multi-species exploration. And Colin was a great guest. He's very easy to understand and follow while still being informative and getting to the point that we want to know as anglers. And I think that can be tough to find sometimes. So I'll quit yapping here. Let's get to what you all came for today. This is our full conversation with researcher Colin Dassow. All right, ladies and gentlemen, today we are joined by Fisheries Research Scientist at the Wisconsin Department of Natural Resources, Colin Dassow. Colin, thank you so much for stopping by Tackle Talk today.
Yeah, thanks, Andrew. I'm excited to be here. Excited to talk about some fish research.
Yeah, before we jump in, I mean, Fisheries Research Scientist probably I still think has to be like the coolest title that anybody can ever have because you get to combine these things that all of us love so much. It's like, yes, I really love the sport side of fishing, but I also love learning about the science side of fishing. I really enjoy the learning aspect of this part of things because we get so caught up in marketing and, bait talk and all that kind of stuff where it's like, this is the stuff that I think, if you want to spend minute for minute listening to something that could really help you out on the water the next time you go out. So I guess for starters, how did you get into this field? Like, were you a angler at heart and then you saw that there was a scientific side, or was it vice versa?
Yeah, that's a fun question. So I grew up in southeastern Wisconsin. I spent a lot of time outside fishing, hunting, doing that kind of stuff as a kid. And so when I went to school, I knew I didn't really want to have a job that wouldn't let me spend at least some of the time outside. And so I just started kind of looking for opportunities to work outside and got a few lucky breaks here and there where I talked to the right person at the right time and they were hiring, and I tried some things out, and that's kind of how I worked my way from what I started doing, which was like water quality, what's called limnology studies of like lakes and some like chemicals in the water and nutrients and things like that. And then I started slowly working my way towards fisheries because I found I just I really liked the work that I got to do with fisheries, and I really liked being able to talk to anglers at the boat ramp when I was out doing my work. And there were some opportunities to get paid to go fishing, and that's never a bad thing. So yeah, I was able to work some of that into my degrees as I kind of moved up through school.
So growing up in Wisconsin, then as you were younger, were you mostly a walleye guy? Were you a bass guy? A little bit of everything?
Mostly, I would say panfish and walleye.
Okay.
As a kid, for whatever reason, I was obsessed with catching bullhead for like 2 summers. I like begged my dad to take me to the river because I really, really needed to catch bullhead for whatever reason. I don't know why. I was like 5 or 6 years old. But we did that for a while, so I have some good memories catching bullhead as a little kid as well.
So then in your industry, I guess, when you decide to go into, whether it is fisheries or this side of things, I'm guessing it's like most things where there's a private and a public sector to it. So you are kind of in the public side of things. You work for the state. When someone goes into this, are the majority of people going into the state research side, or is there a lot bigger opportunity to go like private, whether it's pond management or, if it's a private property that they're helping with? Like, is there that weird kind of like dichotomy between private and public in your sector?
Yeah, I would say the majority of people work, in the public sector, whether it's for a federal government, state government, tribal government, or like universities. There's, I would say, a growing number of positions in sort of the private side of the industry, because, like you said, there are consultants who do lake and pond management, get to some of the places that we just don't have time to get to. And there's a lot of things we use in our jobs that other people make. So like the tags that we put in fish and the scanners that read those tags, like there are private companies that employ fisheries scientists to help do the research and development to build the equipment and the tools that we use in our everyday jobs too.
Is it a in-demand job? Like, I feel like I've heard people say before, this might be like an old wives' tale, but like to be a game warden or like in the ODNR, in my case, like here in Ohio, like is a very in-demand job where it's like really hard to, become that because so many people want to do it. Is that the case with like fisheries research too? I have to imagine, especially the past, 5-10 years, I feel like fishing has gotten cool again. And it probably has led to a new generation of people that want to look into this as a career. Is it a pretty competitive field?
Yeah, it definitely can be. I think it's especially competitive because, one, there's a lot of people who want to do the work, but also like the jobs, there's not always a ton of those jobs available. So you have a lot of people going kind of for a small number of positions. So for example, the job that I have with the state of Wisconsin, I'm one of 6 fisheries scientists around the state. So like there's only 6 of us. So when one of these jobs opens up, which isn't very often, there's a lot of people who would like to have this kind of a job for sure.
Well, you get to do some really cool research, and that's obviously what we're going to talk about today. So, as is usually the case with these type of episodes, I stumbled across one of your really recent research projects, I think. I think this one was like released last month, and it was in aquaculture, fish, and fisheries, and it was titled Abiotic and Biotic Factors Influencing Largemouth Bass Growth in Wisconsin. And as someone who is interested in and invested in the growth of large fish, obviously to try and chase them as, trophies at some point, that was one that really caught my eye. So I started reading it, and then I realized really fast that I was probably a little bit over my head in terms of trying to soak up everything that you'd done in this research project. Like, I think sometimes I'll look at someone and be like, oh, okay, this is pretty, easy and simple, and I got the gist of this, in 30, 40 seconds. It's like, I can kind of figure out where you're going with this. This was very data heavy. There were charts, there were everything, and it was really cool. And I was like, oh man, I might be like a little bit over my head and over my skis. So I emailed you. You were kind enough to respond. We hopped on an initial call, and I told you before we started recording here today too, I said I really appreciated on that initial call that you are one of those guys that can really, and I mean this in the most respectful way to everybody listening and to you are able to sort of dumb it down a little bit so that people like me can understand exactly in like layman's terms what it was you were trying to do. And I think this study is a really good example of that. So I guess I want to start with this one. There's like 2 more studies I want to ask you about too once we get to those. But for this one, even in the title, there are some words that I think if people are driving in their car right now, they might not be even familiar with, like abiotic and biotic. Like, what does that mean? The factors you were looking for to say, hey, this is what I would look for in a fishery to grow sort of trophy bass. What is an abiotic and a biotic factor, and what were you guys really trying to understand here?
Yeah, so abiotic and biotic are two words we use a lot. Abiotic means not alive, and biotic means alive, right? So abiotic characteristics of a lake might be things like water clarity or water temperature. Biotic characteristics of a lake might be things like the aquatic plant community or other fish species, things of that nature. So yeah, not alive versus alive. That's sort of what we're hinting at there. Is we wanted to look at different parts of different lakes that might give us a clue as to whether they can grow large bass or not.
Was there a reason you can point to where like it was the genesis for this to say, hey, this is a project I want to undertake? Like, was there a policy implication? Was there a phenomenon you guys saw that you're like, I'd like to, dig into that a little bit further?
Yeah, definitely. So one of the leaders of this work was actually a technician that we hired fresh out of college named Ryland Thomas, who lived kind of near where we were and wanted a job to kind of get his foot in the door with the DNR. So we hired him, and he was really, really interested in bass fishing and wanting to kind of learn how to do research and stuff. So we started talking about, you're interested in largemouth bass. Bass are becoming a little bit more popular in Wisconsin than they used to be, and they're much more common in lakes than they used to be. One of the things we see in Wisconsin as the environment's changing, some lakes are getting warmer, right? And some lakes are staying kind of okay, kind of cool. And we have different fish species that like warm water and cool water. Bass tend to like warm water. Species like walleye tend to prefer cooler water. And so some of those lakes that used to be walleye lakes have heated up enough now that they're becoming more like bass lakes. And so there's sort of, if we're looking into the future as far as fishing goes in Wisconsin, there's an expectation that bass may become more common on the landscape. And certainly they're popular with anglers, and there might be opportunities then to provide some really nice bass fisheries in places as sort of walleye disappear in those lakes as they get too warm. We can provide some good bass opportunities as an alternative. So that's sort of one of the policy implications. And then, Ryland's interest in bass fishing in general was we had someone there then who we could work with and was excited to do a lot of the legwork.
Well, and what this kind of, the question it raised in my mind, and I'm sure this is probably the question you guys are answering, is like, I'm assuming if you are managing the fisheries for Wisconsin, I mean, you're not just managing bass, you're managing, 20, 30, 40 different species at a time, and trying to balance all of those. You're like trying to find a good mix of things to keep this lake healthy, because things that might keep it healthy for largemouth are not things that keep it healthy for panfish or for pike or for catfish or whatever. Like, every species and subspecies has its own little nuances, and I'm sure that's kind of the tough part as the state to manage a fishery that's diverse, is to say, well, I'm trying to manage the interests of these 7, 8, 9, 10 different species at the same time. And the cool part about this study was, all right, let's isolate largemouth bass. Let's go down largemouth bass and let's say, what factors can I determine or look at all of these different lakes and all this different data and say, what is really applicable just specifically to this species? And I think that was cool. I think that's an interesting lens to look at for sure, because I think sometimes we all just think, healthy fishery is a healthy fishery. It's like, I'm sure in your guys' shoes, that is not the case. Like, it might be a healthy fishery for 3 of the 5 species in that lake, but maybe not the other 2.
Yeah, absolutely. That's a kind of a common question we'll get if we're at a boat launch and someone's asking us how things are going is, how's the lake doing, or how are the fish doing? And my first response is usually, well, what fish are you interested in? Because the answer you get will sort of depend on what you're interested in. It might be going well for some species out there and not for others, like you said. And we have a pretty diverse group of anglers in terms of like what fish they like to fish for. So we're trying to meet the desires of all of these different people who kind of want different things out of the same lake, and try to understand how the fish are interacting with each other, because they're all, trying to eat the same food and competing for space and food. So Yeah, it's definitely complex.
When you're trying to manage a large fishery like that, this might not come across the right way. I won't ask this, but I'll try it anyway. So is there a hierarchy of species that you prioritize in a lake? Like, I don't mean it necessarily as like, well, yeah, bass, we like them better than carp or something. I'm saying more like for the health of the fishery, like, does it start from the bottom up? Like, are you guys worried about the bait and the, phytoplankton, all that kind of stuff like first? Or is it like, no, it starts top down and we do have kind of like this pecking order of what's most important to Wisconsinians and like, what should we focus our efforts on?
Yeah, definitely. I would say we have some species that we focus on a lot more than others. So one of the things we try to think about when we approach a lake is like what's the native species here? What's sort of the norm? Like, is this a walleye lake? And so that's kind of a good base to start from. Is like, this is a walleye lake. It's always had walleye. They've always done well here. We're not going to try to make it into something that it's not. So we try to think about like what's appropriate for that water body and its characteristics. And then from there, we might think about bait fish and stuff like that. That might be how we achieve our goal of maintaining a nice bass fishery or something like that. But yeah, we try to think about what is that lake already set up to provide and how can we work with that.
So in this particular study that we're talking about to start out then, I know you said obviously we're looking at, all right, it's living and non-living factors. And I'm sure, non-living can be anything from boat docks to ledges to dead logs and wood, rock, all of that. And then you've got the living side of things, which is your, aquatic vegetation and all of that type of stuff. So I know you mentioned a few right off the bat, but was there a list of like, I don't know, whatever it is, 10, 15, 20 different things that you were looking at each of these bodies of water in particular?
Yeah, absolutely. So let me pull it up here. We were interested in some things that we knew from previous work were likely to be important, but people had never really had a chance to kind of compare and contrast to see which things are most important or not quite as important. So we looked at things like the catch rate of panfish species. That's, that's a prey item for largemouth bass. So we thought, maybe if there's more of those around, maybe those are lakes where you have bigger bass. We looked at the percentage of the lake that is sort of shallow water, 3 feet deep or less. We looked at because that's sort of, where we might expect fish to be able to spawn and forage. And if there's more of that habitat available to bass, maybe they would do better. We looked at things like the watershed land use. If the watershed around a lake is all forests versus is it all parking lots because you're in the middle of a city, does that influence what is available to bass in the water in terms of nutrients and maybe pollution or something like that? So we had a whole list. We looked at aquatic plants. We looked at riparian land use, which is basically land use in that first 300 feet of land from the water's edge upland. Then we looked at watershed land use. We looked at something called conductance, which is how well the water conducts electricity, because that is usually a good proxy for like nutrient availability in the water. And then we looked at some basic lake characteristics, like what's the average depth of the lake. Like I said, how much of it is shallow habitat versus deep water. So yeah, we were kind of working off of things we knew mattered from other studies. And then we tried to find as many lakes as we could that had all of those pieces of information measured already, because we weren't going to be able to go out and take additional measurements.
Yeah, this was where when I started reading into this, some of this stuff, I was like, I would have never in a million years thought to try and measure or quantify or compare like conductance. like dumb redneck guy here, isn't all water just, I don't know, if it gets struck by lightning, doesn't the same thing happen? And you're saying like, no, there's probably differences in that makeup of that water, whether it's, if it is choked up with weeds, whether it's got more, zooplankton in it or whatever, I don't know, probably like silt and all that kind of stuff probably changes the conductance of that water. And that could be like something that you look at and say, okay, does it matter to a bass how far lightning goes if it strikes it? No, but that tells you something about the water makeup itself.
Yeah, absolutely. Absolutely. Water definitely has different conductance. Just as a little aside, one of the techniques we use in fisheries management is electrofishing. So we use electricity to go out and sample fish by stunning them. And some lakes, it's very easy because the water is very conductive. And in other lakes, it's actually really hard to get fish to stun because the water does not conduct electricity very well. Like it's really like the electricity doesn't travel very far. It doesn't, it's not very strong when it hits the fish. So yeah, there's definitely some lakes that are more conductive than others.
Do you know what that's due to?
Yeah, so it tends to be because of, like I said, like a lack of nutrients. Like some of the very clear water, like nutrient poor lakes around here are some of the ones that have lower conductance. Like you could drop your phone in that lake and take it back out and it's going to be fine because it's not going to short out because the water is not very conductive. But other lakes, you can't get away with that.
Yeah, I have a lot of phones and cameras that have, I guess, been dropped in some pretty conductive lakes over my life. So that's like the factors you were looking at as far as the body of water itself. Now there's probably the other side of the coin that says whatever factors you're looking for in the fish, like what tells you, all right, this is a lake that we've identified that does have healthier, whether it's girth, length, weight, like whatever. What were you guys looking for on the fish side?
Yeah, on the fish side, we were looking at what's called relative weight. So we took all the largemouth bass that were age 5. So we wanted to just be working with fish that had the same amount of time to grow. So we took all the age 5 largemouth bass that we had in the state, that we had measurements of length and weight. And then what you can do is you can calculate what's the average or the standard weight for fish of that age. And then we can compare that weight to that average weight to each of the individual fish's weights so that we can say, okay, here's a fish that's way above average and here's a fish that's way below average. And that relative weight tells us, how sort of chubby a fish is compared to average. And so lakes that had higher relative weights give us an indication that, okay, that lake seems to have fish that are on average much fatter than fish in another lake. So that would tell us that they're probably doing a little bit better.
Yeah, and I'm guessing there's a difference that we should probably talk about between the ability to have a trophy fish population versus just fish population in general, because those are two totally different things, right? If you have a great numbers lake, that could be the worst lake in your area if you're out looking for a 5+ pounder. So in this study, you are specifically looking for, like, healthy to you means the healthy individual fish, not the lake you can go out and catch, 19 line burners an hour. And yes, there's a bunch of fish in there, but they're all stunted.
Yeah, absolutely. Right. We're thinking about catch size, not catch rate, which is kind of the terms that I would use to think about it. But yeah, all fish species have what we call a density dependent relationship. And all that means is that, like you said, you can either have a lot of fish that have a small size, or you can have a few fish that have a large average size. So you can't usually have a lot and also have big fish at the same time. There's only so much food to go around. So yeah, that's what we were thinking about, is we're thinking about that big fish end of the spectrum.
So did I see, when I was reading through this, the number of years that you were able to look over for at least some of this data was like almost 30 years, right? I think there was some data you had that went back to like 1994. As a researcher and someone that's trying to put together and compile that much data over what's almost 3 decades, like, does it present any problems for you ever? How that data was captured 30 years ago probably is way different than what you're doing now. Things are incomplete. You just wish there were things you could go back and snap your fingers and you had from 30 years ago that now you can go out and do. Like, is it frustrating sometimes trying to put that wide of a data set together?
It can be a little bit. In this case, if there were spots where we didn't have data, it wasn't necessarily the case that we couldn't have collected it. It's just that maybe we didn't think it was so important at that time to be weighing as many largemouth bass as we were. And so like the methods from 30 years ago are pretty much the same methods we use today. We try to be very careful about standardizing the way that we collect our fisheries data, because we want to make sure that what we see today for numbers is comparable to something in the past, because we've collected the data the same way. And that helps us a lot. So yeah, it can be a little bit, generally the older data is a little bit sparser, like I said, where maybe we didn't spend as much time weighing bass as we would have now or something like that. But the methods are all the same.
So I guess that brings us to the magic question for this study then, which is, what did you find? Like, you've got all this data, you did all of this research, and you're trying to answer that question of what factors in a lake that I can kind of identify and make a list and say, hey, if I was looking for a lake that can grow trophy bass, here are the, 2, 3, 4 things that we saw across the board that seemed to kind of be a pattern. What did you guys find?
Yeah, so the first thing that really jumped out at us is one of the things that was most commonly associated with big, heavy bass was what we called tolerant macrophyte species. So these are aquatic plants that are tolerant of like kind of harsher conditions. So these are plants like common duckweed, Eurasian water milfoil, curly leaf pondweed. These plants can withstand sort of like rougher or more disturbed water quality. So lakes with sort of lower water quality, these plants will still survive in. And we tended to find that our bigger bass were in those types of lakes. And again, those are also lakes where we don't catch a lot of bass, highlighting again sort of that trade-off between numbers and size. The other thing we found was that lakes that had more sort of intact plant communities, that had some of the more sensitive species that would disappear if they were degraded a little bit, those lakes tended to have smaller bass, and they were also the lakes that tended to have more bass in them. And then lakes that are sort of warm water lakes or clear water lakes tended to have bigger bass, or more bass that were smaller, whereas lakes that were sort of cool water lakes or sort of turbid or almost riverine, like if they were a flowage or a reservoir, those lakes tended to have bigger bass in them and smaller ones, which again sort of makes sense when you think about it, right? Largemouth bass are not a river fish. You can find them in rivers, and often where you find them will be wherever the current is weakest, in deep holes or in backwaters. That's where they tend to do better. And so certainly in these cooler lakes or lakes that might have more current in them, because they're a reservoir, we have fewer bass, but again, they had a chance to get a bit bigger because they don't have to work quite as hard for all their food or compete with other bass as much.
Yeah, there's a lot to unpack there that I think is really cool. First off, I think is just the overall look at like aquatic plants. Like basically what I get from what you just said is aquatic plants are good, and I want plants that stick around and not plants that are wussy plants that, can kind of die out and then leave these bass SOL with no plants around. Like that seems to be what it is. I want like fighting plants that can deal with different water conditions, different everything. So on the train of like plants are good, we like plants lead to maybe less bass, but bigger bass. Why is that? Is it just because more plants mean more cover and they can, hide better, and then they're obviously living longer and they're growing bigger? Is it more of like an oxygen or a bug thing? Like why are plants overall such an important part of that equation?
Yeah. So one of the like kind of core pieces of like fisheries science is something called foraging arena theory. And foraging arena theory is kind of what it sounds like. Like picture like some sporting arena where you have like all this, all the players are sort of forced into the same area and they have to compete with each other. Like that's kind of what a lake is, right? Like all the prey and the predators have to be in the same area and they have to find ways to survive. Both of them do. And so aquatic plants create these kind of little arenas where inside the mat of plants you can have little fish that are surviving and eating bugs or eating zooplankton and trying to not be eaten. And around the edges of that plant mat, that's where the big fish are going to be hanging out, waiting for that one little fish that wanders a little too far away from the plants. Like that's a foraging arena. And so what we think about with the tolerant or like the hardy macrophytes or the hardy aquatic plants and the big bass is that, when a lake is sort of getting to a point where those other plants are leaving, right, and the water quality is maybe not as good as it once was. One, bass are a really tough species. They can live anywhere. As I'm sure you've realized, you can catch bass in a lot of places and they seem to do just fine. But two, those bits of plants that are able to continue to eke out a living there are some of the last places that bass can go to look for food. So those are going to be the places that draw them in, perhaps, and the places that still provide some food for those fish to keep growing. And it might be that it's actually easier to forage in those areas for bass than it is in other lakes that have really kind of diverse, varied species of aquatic plants. Maybe they can find food a little bit easier amongst curlyleaf pondweed, that kind of thing.
Interesting. It's almost like, so I'm a river guy around here, and around here it's you find the biggest smallmouth at the like tail end of that current seam because it just makes that buffet of bait coming their way. Like that's kind of what the weeds sort of do, right? It gives this bass something to relate to and say, hey, here's where my food is going to be hanging out. I don't have to mosey around this vacant lake all over the place, roaming in search of where my food is going to be. I know where they're going to be. Like I have these areas that just have the weeds have the bugs have the small fish hang out there, and I can just sit on the edge of this weed edge and just feast all day long, and I don't have to exert so much time and effort finding my meal as it is just hanging out in the right area. I think that's an interesting point there too. And then the other side is like depth or riverine, I think is what you said, aspect of some of these places. That's interesting too, because basically I think what you're kind of saying is like, I want a fishery that doesn't quite set up as well for largemouth bass, because then there won't be as many largemouth bass, and the largemouth bass that are there are going to be bigger.
Yeah, absolutely. Like one way to think about it might be if you're interested in trying to catch big bass, you might go to like a walleye lake, because there's not going to be a ton of bass there, but the ones that are there are going to be pretty big.
That's so funny. The best largemouth fisheries are bad largemouth fisheries.
Yeah, if you're looking for sizes and not numbers, exactly.
That's cool. That's total opposite of what I would have thought, right? You would think that, I want this place to set up perfectly. I want docks and laydowns, and I want no flow, because flow around here is smallmouth city, and I want this like stagnant water. And it's like, well, yeah, you might have 3 times as many fish in there, but you're not going to have the 6, 7, 7.5 pounders that you're hoping for in there. That's cool. This is what I love about research, is just, okay, someone can take that and say, yeah, this area or this lake that I thought probably wasn't worth fishing. It's like, well, it depends on what you want. Do you want a place where you can take a 7-year-old and you can wear him out on a rooster tail? Then yeah, that might not be the right fishery for you. But if you want the place where you can grind it out and there's probably a fish of a lifetime swimming around there somewhere, then don't discount those fisheries.
Yeah, absolutely. And I was actually reading a research paper from a group down in Texas that just came out this month, where they were kind of doing a similar thing. They were looking at entries into the Texas like largemouth bass lunker contest or something like that, where like anglers could submit their big bass, and they were trying to figure out which lakes are these bass coming from, and what are the characteristics of those lakes. And they had that, and it just, I think, highlights some of the difference between like northern kind of temperate bass fisheries and southern bass fisheries, because down there, it was the case that more of the big fish were coming from lakes that were more remote and more sort of pristine and sort of how they would define that down there. Whereas up here, some of the big bass are coming up from lakes that are maybe not as pristine and are not like bass heavens, But yeah, just different places, different rules.
So then I guess the last question I have is on the aquatic vegetation side of things, I guess. I think we've established like, hey, they're good. That's what you want to look for. Is there such thing as too much of a good thing? Like, is there a tipping point where you say, okay, yeah, you've got the right weed makeup and everything in here, but it's too much at this point? Or is it just too much to be able to be fished correctly?
Yeah, certainly you can have too much if your goal is to find trophy largemouth bass. You can imagine a lake that is just like wall-to-wall aquatic plants. It's going to hold a lot of food, but all of that vegetation is going to be hard for bass to forage in. And what probably will happen, we think we see this in some of the lakes around here, is that you have such good survival of forage fish. You have tons of forage fish around that it can feed a lot of fish, but they just have a hard time getting to that food. And so you end up with a lot of fish that are sort of small size, even though there might be a lot of food around. So yeah, I think, you can't have too much of a good thing if your goal is to try to catch big bass, because you might then just end up in a situation where you have a lot of small to medium-sized bass.
So then up by you guys is Wisconsin, like do those areas become really good like ice fishing lakes then? Is that something you see where some of these places where, hey, it's, maybe it doesn't grow big bass, but it's like panfish palooza and you're vertical jigging. So if it's weeds, all right, you find one little 4-inch by 4-inch area where you're not hitting weeds straight up and straight down and it becomes like crappie heaven.
Yeah, absolutely. One of the lakes that I'm working on for a different project right now, not related to bass, is one of the best pan fishing lakes in the state, and it's super popular with ice fishing anglers because of how consistent the sizes are and how many of them you can get. And that lake is full of a lot of small to medium-sized bass and has outstanding bluegill size structure and abundance.
So I guess if I want to pivot here, because I read this paper and then I fell down the, Colin Dassow rabbit hole and I started looking at all the other stuff that you had put out. And the very next thing I found was a study that was titled Counteracting Effects of Hook Avoidance and Hook Habituation, I think it was, to angler catch rates and catch and release fisheries. Basically, it was saying like, hey, how do we not have as big of a deal with fish trying to avoid hooks or fish getting used to hooks and then they're not as likely to bite in the future. And we talked a little bit in our initial call about this too. And I think this was one of the most eye-opening graphs and things that I had looked at in a long time. And this is one of those studies that, again, how I thought and my little redneck brain on how all this stuff works is not what the data shows. So can you give us like a, bird's eye view of what that study was like and where that came from and what you guys found there?
Yeah, absolutely. And I agree. We thought we were probably going to see one thing. We didn't know for sure, but we ended up seeing something totally different and something that I don't think anyone else had ever seen anywhere. And so the idea with this study was we had these two small lakes in northern Wisconsin that were completely closed to the public. So we kind of had full control over them. And we wanted to figure out if increasing fishing effort, basically, if more people fishing on a lake would lead to a decline in catch rates for largemouth bass because more fish are getting caught. And then that hooking experience is making them not want to bite in the future. Like, could we end up sort of, even though the number of fish isn't changing, could we end up kind of tanking our own catch rates just because we're out there fishing all the time? And that's not what we found, actually. So what we tried to do was we had one lake where we just kind of fished it at the same constant level for a whole summer. And the other lake, we started off fishing at that same level. And then halfway through the summer, we doubled the amount of time we were fishing on that lake so that it all of a sudden got this increase in fishing pressure. And what we thought we would see is that once we doubled our fishing effort and we had more fishing pressure out there, we thought that catch rates would decline. More than they would decline in the other lake, because just kind of typical north temperate lakes in kind of the northern part of the U.S., bass catch rates kind of always decline through the summer, just as part of the seasonality of the fish. But we thought they would decline a lot more once we added more effort, and that's not what happened actually. what we found was that there's an immediate sort of decline in the probability that a largemouth bass will get recaptured. So like you catch a largemouth bass, the next few days, you're probably not going to catch that bass. That's sort of an immediate drop in how likely you are to recatch that fish. And then over time, it slowly becomes more and more likely that you'll recatch it as it starts to kind of forget about that hooking experience. And what we found goes along with that is the more you catch a largemouth bass, the more likely you are to catch it again. So that's not hook avoidance, but like what we would call hook habituation. So like it's just kind of getting used to being caught and doesn't care. And so the amount of time it takes for that fish to go from not catchable to catchable again after you catch it gets shorter and shorter the more times it's been caught in its life, or at least in that summer. And so that was what we found that was really unique and not at all what we thought we were going to find.
Yeah, I would assume that, like, if I was a largemouth or smallmouth bass or whatever, like, I've got, I don't know, you catch me 3-4 times in my life, like, I'm just not eating anything that even remotely looks like it's not the most natural shad or bream or whatever that I've ever seen. It's like, fool me once, shame on you, but fool me twice, fool me 3 times, 4 times, I'm just not doing it anymore. And what you basically saw was like, yes, at the beginning, it was like, whoa, didn't like that, I don't want to do that again, I'm going to be very, very cautious from here on out, because that was the shock of a lifetime. I lived my whole life, and then I just got abducted by aliens with a sharp razor went through my mouth, and I'm not doing that again. But then as, time goes on, like I said, it forgets about that. Well, then it slips up again and it, eats something else that was, on a hook, or it eats a lure or something. And then it seems like that fish is basically saying after a couple times, because the chart that you had showed that the time in between hook recapture would get smaller and smaller as it went on too. So basically, after the first hookup, maybe it takes a week before it bites again. And then after the second hookup, it's, 4 days before it will bite again. And the third hookup, well, now it'll bite after 2 days, because what it's probably saying, I guess, to me would be, all right, I didn't die doing this, so I would rather go around and eat like a maniac and just go ahead and take a shot at it, because best case scenario, I get a real meal. Worst case scenario, all right, it's an unpleasant couple minutes and I'm right back where I started.
Yeah, absolutely. And I think just off the top of my head, I think some of the fish in that summer we caught 9 times in one summer. A lot of the fish were caught at least 2 or 3 times. I think we caught 94% of the bass in the lake. So pretty much every fish got caught at least once. A lot of fish were caught multiple times, and then some of them were caught a ton of times. Like you said, the more they get caught, the less they seem to care about it, and the shorter that time is before they get caught again. And like you said, I think the big thing for them is they're looking for food. They got to eat, and so if you didn't die, then you might as well keep going and see what you can get. Keep trying.
Well, and I would guess those fish that just keep getting recaptured, like those are probably fairly healthy fish as long as they're taken care of by whoever captures them, because they're taking risks. Like they are the risk-taking fish where they're going out there and they are sticking their neck out and eating more. I mean, I can think of a couple instances around here where, I always like affectionately refer to it as our hilljack way of tracking fish, is just we can photo match fish from like years after, apart from each other or whatever, where they've got a weird fin or they've got a unique marking or something. And the fish that we recapture and we have like photo evidence of typically are the larger fish. It's like the alpha fish in that stretch of river or in that portion of the lake or that cove or whatever that fish is kind of stuck around, and we catch the large fish over and over again. And I would assume it's because, hey, that fish got large for a reason. It's eating a lot and it's not afraid to take risks. It is that alpha male or female or whatever that's around, and it may not be as bad of a thing as we think it is.
Yeah, absolutely. And the other kind of nice thing about that is, for the species where we tend to catch and release instead of catch and harvest, like people might worry that, maybe there was a fishing tournament here. There's a league fishing night last night. It's probably not going to be good for me to fish there today. It might not be bad, actually, because enough of those fish might be kind of used to being caught. They're not going to care. They'll keep coming back at it. So that's kind of neat. And like the whole study we used the same soft plastic worms the entire time, same pattern. We had 2 patterns that anglers could choose from, and that was it. So like,
so you weren't even tricking them. This is like,
no,
it knows that this is the lure and this is not real. Like, you're using the same green pumpkin worm or whatever you've used over and over again. So this is truly the fish not caring, not saying, oh, you got me last week with the crankbait and now it's spinnerbait time. And okay, well, yeah, I fell for that one too.
Yeah, no, nothing like that. We were not switching it up on them. So yeah.
That's so cool. So what did, like, on the other side, the lake that you didn't double the fishing pressure in at all, were you still seeing kind of the same thing mirrored over there too?
Yep. Yeah, we saw the same pattern in that lake too. Because we didn't double the fishing pressure, we didn't catch quite as many fish, but the same pattern still held, which was, really interesting stuff. And the other thing we found there was that we didn't notice, this is true for both lakes, we didn't notice in our analysis, we couldn't identify any signal of like it being an individual fish characteristic. Like, the pattern seemed to hold across all the fish we caught. It was not something that was unique to just like a few fish, which again is pretty interesting and kind of goes against what we thought we might find. And what you sort of alluded to earlier is that like there's probably some bold, aggressive fish out there, and there's probably some shy ones. I don't know. We like I said, we caught 94% of the bass that you could catch in this lake, in these 2 lakes, and they all kind of did the same thing. So at least, in this situation, it might not be the case that there's necessarily bold and shy fish, or at least not so shy that they never get caught.
Yeah, you weren't seeing, the dumb, young, small ones are the only ones we're recapturing, and we're not catching anything of size over and over again. You were seeing that across the board, like, age, size, weight, length, like it was just an overall pattern you were seeing.
Yeah, absolutely.
Again, one of those things that shakes every bit of conventional wisdom that I've been told for my whole life is like, I hooked that fish yesterday. It got hooks. I didn't land it, but I know it got hooks. I got to give it at least like, a week. No, it could bite an hour from now. Go back to there, right? You don't know how shy those fish are. And you had some verbiage in here too. There was like the verbiage of, I think, hyper depletion and hyper stability in there too. So I think those are like, I'll let you say it, but I think they're fancy ways of saying like, is the number of fish I'm catching like per hour, whatever, declining, or is it just staying the exact same no matter what?
Yeah, absolutely. Those are 2 phenomenon in fisheries that like I didn't know about until I started getting into the fisheries research world, and they're super interesting and quite widespread. And some work that I did early on actually provided sort of the first evidence that they could happen in recreational fisheries, because we'd seen them in commercial fisheries for a while. Both of them refer to the question of, does the number of fish I catch per hour as an angler today, is that reflective at all of how many fish are in the lake? Hyper stability is one side of the coin, where the number of fish you catch per hour stays the same even as the population of fish is declining. So as an angler, you might go to a walleye lake and you're filling your bag every day, you're getting your 5 walleye in about the same amount of time. So to you, it seems like the population stands steady, and you might do that for 5 or 10 years. But the number of adult walleye in the lake could actually be declining, and it is actually possible for that to happen. And that's what some of my earlier work showed. And what that can mean is we can accidentally, without even realizing it, overfish a population. Like, not even trying to, you could accidentally overfish a population. And we knew this could happen because it's happened a lot in commercial fisheries. Like when you think about collapse of different commercial marine fisheries, like the cod off Newfoundland, that's probably because of hyperstability. So that's sort of one side of the coin, where the number of fish you catch is much higher than what's in the water, and it fools you into thinking everything's fine. The other side, which is sort of where we were going at with this hook memory and hook learning experiment, is you could fish every day or every year, however you want to define it, and the number of fish you catch per hour could decline even though the number of fish in the water is not changing. So in that case, you might think the number of fish in the population is going down because you're catching less and less every time you go. when in reality it's staying the same. And there we thought that if fish are able to learn to avoid hooks, that's what would happen. The number of fish wouldn't change, but they're learning to avoid hooks, so you catch less and less each time you go. And that's ended up being not what we found.
So if you have hyperstability in a fishery, I don't know how you diagnose that, right? Because the anglers or nobody's reporting a decline. You're not seeing a decline. How do you, as a fisheries, management side of things, how do you deal with that? Because unless you're going through and shocking the whole lake and trying to figure out what's in there and what's not in there, you're just going to think the lake's totally fine while it's declining for years and years and years.
Yeah, exactly. That's it's a really tricky question. And one of the things we try to do in Wisconsin is we try to get out and survey, actually do our own independent estimate of the number of fish in the lake once, every 5 to 12 years ish, depends on what part of the state you're in. Some parts have more lakes in them, we can't get to them as often. Some parts have fewer lakes, we can get to them more often. That gives us kind of a quick look to see if things are kind of going okay still, or if they might be declining. But if all we have to rely on is what anglers tell us, then yeah, it's really hard for us to know for sure how things are going. We can do some other stuff with statistics. We don't really have to get into that, but basically we can look at the production to biomass ratio in a lake. That's probably deeper than we need to go here, but basically it's just a way for us to try and understand, is this fish producing a lot, or is this population of fish producing a lot of biomass or not? We can use that to help as well.
So if you have a situation where you're able to diagnose and you say, yeah, this population of whatever is going down, even though everybody in the world thinks it's not, and it's fishing just as good as it ever has, on the policy implication side then from the state, I'm guessing next steps on that would be all right, well, we need to implement stricter limits or things like that to let this fish bounce back. And then I'm sure you're met with just a public outcry of what do you mean you're putting restrictions on this lake? It's never fished better. And they're like, well, trust me, the population's going down. And then you got everybody like me. It's no, it's not.
Yeah, it can be hard, right? We might have some information that tells us it's declining, but yeah, for the average angler, they're out there, fishing's just as good as it's always been. Why do we need to tighten up the bag limit or change the length limit out here? But yeah, what we would do in that case is we would think about more restrictive fishing regulations, potentially stocking if that is going to need to happen. If it's so low that we want to stock to try and push things back towards a better spot. But ideally, if we could just put a stricter regulation on it, give that lake a few years to sort of bounce back, and then we can return to more of a normal situation.
Tough situation to be in, because I know that, we all know that as an angler, I know more than you do. I fish here twice a week. I know you've been studying this place your entire life and you have all the data in the world, but I fish here twice a week, son. And I know that this population is totally fine. And now you have Facebook population time frame where it's now you get to see everybody complain in real time. So I do not envy that side of the state's job at all. But I think you guys are probably seriously the most unsung heroes, because all anybody does is complain about anything that the DNR or whoever does. And it's do you enjoy the nice fisheries you have on the weekends? There are people that spend 24/7, 365 making sure that lake is fishable. So we appreciate that.
Yeah, absolutely. And we do actually get a lot of help from anglers too, in a lot of ways, because at least in Wisconsin, there's more lakes than we can get to in a year, right? So we kind of have a rotation. So it can be useful to talk to anglers who spend time on lakes that we're just not going to get there for the next 4 or 5 years. Are they seeing anything at all? Maybe they don't notice anything, and that's okay. But if they do, then it might give us a chance to sort of get in there a little bit earlier as well. So they're kind of bonus DNR employees when they let us know that something.
Boots on the ground.
Yeah.
Yeah. Well, the last thing I want to chat with you on, and this is more kind of selfish for me, I guess, too, but I know we were talking, and you've done some really cool studies on musky and pike. And one of the things that was interesting to me was how the relationship between those two species work. Because, I mean, I'm in Ohio. We do have some okay musky fisheries around us that the DNR stocks, and we've caught some decent ones, but there aren't very many lakes around here where we have musky and pike competing. Like, you're going to find pike in the river systems if you go up a little farther north, and you're going to find musky in the lakes that they stock musky. You're not really going to find a lot of overlap, but I assumed, because I'm, again, just simpleton here, is that from what I've done fishing for both of them is that they're fairly similar species. They have some nuances, obviously, where, you know, a pike can come from 4 zip codes away to absolutely smash anything you're throwing out that's got any bit of flash in it, and you can throw that same thing by a musky's face 10,000 times and it just stares at you like you're stupid. But I mean, they have some quirks, but they are fairly similar looking, and I'm sure they're probably somewhat related. But you did some cool research to figure out, like, all right, what does that relationship between pike and musky, populations in certain lakes look like, and all of that kind of stuff? Can you shed some light there?
Yeah, absolutely. And this is ongoing research, so I don't have any like real solid answers to give you yet today. But the basic question here is, in parts of Wisconsin, we have lakes that are native musky lakes. Musky have been there since the glaciers receded. And we've never had any pike in those lakes. And then at some point, in the recent past, pike were brought into those lakes by us, meaning humans. And
not Wisconsin, like you guys didn't purposefully put them there.
Okay. Wisconsin GFR, although that is always a rumor that's out there. But
in the dead of night, you just went to sabotage all of these fisheries. You're like, it would be really fun. Let's put some pike in here.
Yeah, I'd love to make my own job harder than it already is. At some point, pike get introduced to these lakes. And what tends to happen is when pike get into the lake, their population goes up, musky population goes down. And then you end up with very few musky. And they're already big fish. It's not like they get that much bigger once there's few of them. So you end up with few muskies, and you lose this musky fishing opportunity that you had. You get a pike one, which you tend to be less excited about in general, although some people are big fans of pike. And pike are native to the general area of Wisconsin, right? They're not a non-native invasive species, but they can be invasive in some specific places. And so one of the lakes around here has a relatively recent pike introduction. The first pike we ever found in that lake was in 2002, and we had been surveying it since at least the 40s. And so that fish at the earliest probably got in the late 90s. And so that a lot of our other lakes that have pike introductions that happened, in the 50s and the 70s, so they're sort of further along on the progression. Their musky populations have already declined. And this is a lake where that hasn't happened yet. We still have a pretty strong musky population. It doesn't need to be stocked. They're reproducing. They're doing it on their own, which is fantastic. But the pike are becoming a concern here. And so we wanted to use some new technology that hasn't really been accessible until recently, where we could implant acoustic tags into pike and musky, and that would basically let us follow them around 24/7, 365 for 4 years. And one way to think about this is it essentially gives us like forward-facing sonar for the entire lake, everywhere, all the time. Like, these fish have these tags in them that are pinging. We have hydrophones, which are just microphones you put in the water, all around the lake, listening for these pings. And we can use basically like geometry and physics to triangulate fish positions based on which hydrophones are hearing fish and how far apart they are. So that gives us the locations of these fish to within about 6 feet. And we have that location once every 3 to 5 minutes, again, for 4 years straight. We're only a year and a few months in so far, so we've got a long ways to go. But the idea is we want to try to understand, like you said, why is it that these fish are so similar that they can actually interbreed and hybridize and produce tiger muskies, yet why do they seem to not get along when they have to live together? Why are they competing for food? Is one of them sort of pushing the other one out of spawning areas? Is one of them just better at spawning than the other? What is it? So that's what we're trying to learn, is by following them around for 4 years, can we figure out, are there any differences at all in where they're spawning that might mean that one is more successful than the other? We think, as far as any of us know, that pike and muskie like to spawn in the same areas. They hybridize, so they must be in the same place at the same time, at least occasionally. But if you talk to some of the old muskie guys around here, some of them talk about, muskie maybe don't always pick the best places to spawn, and pike maybe they felt like picked more consistently good places. So there might be something there. Certainly people have wondered whether pike are eating muskies, and that prevents new muskies from growing up and joining the populations. So we're going to try to understand that. So we want to understand spawning dynamics, and we want to understand foraging. We want to understand, where do these fish like to be? When do they like to be there? And so at the same time that we're tracking all of these fish, we are also mapping the whole lake, also using sonar methods. So we can essentially create heat maps of where vegetation is. We can create maps of how hard the bottom of the lake is everywhere, so we know what types of substrate they like to be around, what types of vegetation clumps they want to be around. We have GPS location of every single piece of wood in the lake, so we can look at woody structures and figure out which ones and when do they like to be around woody structures. We have the number of boats that are on the lake, because there's a boat launch monitor there, so we can look and see, what do the fish do on the 4th of July when there's 1 million boats on the lake? Do they just go to deep water, or do they they don't care? Maybe they just do what they always do. So we can even answer some of those kind of interesting little side questions about boat traffic. We can look at weather data to understand how fish are moving as different weather patterns come through the lake. Even if they don't get caught, we can see how they're moving, right? And the fish that do get caught, we can look to see, what were they doing before they got caught? Angler catches one of our fish, they tell us what were they doing after they released that fish. So there's lots of opportunities for us to learn not only about how pike and muskie interact, but what are some of the basic ways that they live their lives. Because we can look at these fish in a way that no one's ever been able to do before. And again, no one's ever tried to do this type of fish tracking with pike and muskie anywhere. So this is a pretty exciting thing that we're really looking forward to seeing what we learn here over the next few years. Fish definitely have a lot to teach us.
That's what's so cool about this whole study in general, is that this isn't like an area of study where everything's already been done 1,000 times and you're basically just trying to do your own version of the study to see if you can buck the trend or see if you can get some sort of a kind of outlier data that maybe disproves something that's happened before or just something statistically significant. It's like, no, a lot of the stuff that people are doing in the fisheries world just has never been done. We haven't had the resources to do it. No one's put the money behind it to do it. Technology has come a long way. You don't have to use just, fin clips and ask people to call in a number if they catch a fish anymore. You can watch a muskie swim around the lake in real time almost at this point. So this is the cool stuff where you're going to find stuff in this study because it's so wide and you're collecting so much data and you're looking for so many things. You're going to be able to look at little stuff like, all right, I've always been told moon phases are a huge part of a muskie's life. What are those muskie doing during the minors and the majors and new moons and full moons? Are they moving more? Are they moving less and hunkering down? Are they going to the feeding areas? Are they going shallow? All that kind of stuff is going to be cool to see because you're going to be able to isolate all of that data and just you're going to have so much that you can say, all right, today I want to look at this and I want to look at this and I can isolate this and go down this rabbit hole. So I think that's going to be really cool. So I know the study is still ongoing. Initially, though, as you're looking at this stuff, because like you said, you can look every 3 or 4 minutes and get pings on some of these type of things. Are you seeing any initial patterns where it's like, hey, pike move all over the place and muskie are pretty still or vice versa?
Yeah, the one thing that I have noticed in the time I've spent with the data so far is that muskie seem to be moving a lot more than pike.
I would have lost that bet too.
Yeah, right. Some people, and myself included, would have thought, muskie must be a little more sedentary. but other people would have said, "Oh no, that totally makes sense." I figured muskie were always moving around, and yeah, we found that muskie have swim a lot more. They cover a lot more distance than pike on average. I want to say off the top of my head, the average number of miles swam in a month for a muskie was something like 650 miles. Which is crazy, and a pike was like somewhere around like 430 or something like that.
Now, is that in like a concentrated area, or are you seeing these fish go across lake, like a little bit of everywhere?
It depends. It's not consistent, which is also interesting. Some of the muskies stick to a pretty tight home range, and they just seem to always be moving around in there. And some of the muskies are moving all over the lake. The pike seem to be a little bit more like move somewhere, stay there for a while, move somewhere, stay there for a while. So they don't put on as many miles, but they don't like just stick to the same spot forever either.
Does this lake that you guys are tracking at have like big creek arms and stuff that come out of it too, or is it just more of like a bowl?
It's not a bowl. It's a chain of lakes. It's 5 lakes. It's got islands and humps and all that stuff. There's a pretty diverse range of habitats. There's a little bit of flow just as the water that comes in at the top of the chain eventually makes its way out the bottom, but it's not like it's a reservoir. So there's not big creek arms or anything like that. Yeah.
We always have a theory around here. There's a couple lakes that muskie are in that have like a pretty prominent, arm or two of a giant creek that feeds it. And we've always thought that like the fish that are up in that creek are primarily creek fish. Like we never really thought fish were leaving from, half a mile up the creek and then going all the way to the dam side of the lake and then coming all the way back. But I'd be really curious to see, because now that may be completely wrong. It may be like every spring you go there or fall you go there, those are completely different fish that were not living in that creek arm before.
Yeah, exactly. Like this is, again, I wouldn't know either. It's where everyone's learning something new here.
Well, hey, I appreciate you stopping by. Again, this is all super cool stuff. I could sit here for 5 hours and pick your brain on this, because it's like an unknown frontier. All this data that you guys are collecting and the ideas that you're having on, well, let's look at this and let's take this angle at it, I think is something that more anglers should be paying attention to, and not just waiting for like an episode like this to come out. Like, go out and do your own research. This stuff is available online. Go soak it in the, North American fisheries journals and all those type of things. Like, you can go seek out those scholarly articles or those scholarly research papers. And from what I've learned from just having the show is like almost everybody I've ever reached out to that has a paper or a research project or something is very receptive when you reach out and want to understand that project more. That's what you're doing it for. That's why you're doing all this research, is to help more people understand it. And I think a lot of times people are a little apprehensive to like reach out if they have a question about, well, what does this mean? What does this mean? And more often than not, people are more than happy to answer your questions or chat with you about it for a second. So that's what I really appreciate about your whole field too, is that, I don't know, everybody I've ever reached out to that has a project or something I have a question about, you guys are like, twist my arm, make me talk about my research for, 5 or 10 minutes. That would be great. So if anybody's listening out there, I would encourage you, go out and search, for scholarly research papers and articles and like the stuff that Colin's doing, because it's very cool stuff. It will help you on the weekends when you're out fishing. And I think we should try and soak more of this in. So Colin, I appreciate your time so much today. Thank you so much. You are welcome back anytime, folks. That is Colin Dassow, Fisheries Research Scientist at the Wisconsin Department of Natural Resources. Colin, thank you, man. We appreciate you.
Yeah, thanks for having me. I would love to come back, and maybe once we have a little bit more data on those pike and muskie, we can talk more about what they're doing.
I will 100% take you up on that. Thanks, Colin.
Perfect. Thanks.
All right, everybody, that is our episode today. We really appreciate Colin's time and his willingness to stop by and chat with us. And he said to me afterwards something along the lines of, hey, these opportunities are really important to us as researchers. And it's probably a good point. They do a lot of incredible research and work, and then obviously they try to get their work out there, but oftentimes it hits journals and publications that us just regular anglers don't really consume or read a whole lot. So it lives in kind of the academic sphere, and those people people circulate it and digest it and really appreciate it, but us regular folks may never get to see it. So that's why I really enjoy these type of episodes. Stuff like this is going on all over the country, in your state, maybe even in your county, that you just have no idea is going on. So I would encourage you, once again, take the time, do your research, seek out this type of information for yourself. I mean, what's going to make you a better angler at the end of the day? Wasting 15 minutes watching a clickbait video about whatever garbage drama channels can drum up this week, or reading a scientific study about the biology of the animals that we spend countless hours targeting? I think we all probably know the answer to that one. So I would strongly encourage you to devote more of your time to things like what Colin and so many other researchers across the country are doing. So with that, I will leave you guys today. Thank you guys so much for tuning in. Keep up with us at tackletalkpodcast.com. You can email us, tackletalkpodcast@gmail.com. We're on Instagram and Facebook at Tackle Talk Podcast, and we'll see you right back here next Tuesday for another brand new episode of Tackle Talk.
Thank you for listening to the Tackle Talk Podcast. Tackle Talk is produced by Andrew Hayes. Copyright 2019. For more, please subscribe on Apple Podcasts, Spotify, or wherever you listen to podcasts.